on to the microscope. So in this video, we're going to do the different parts of the microscope and how to use a microscope. Now, if we were in the classroom, if we were in the lab, this would be the point where we would start using microscopes, see how they work. Unfortunately, we're not going to be able to do that. However, what would be really good is if you could, really get an understanding of how the microscope works, and then next year when you do use the microscope, you won't have to worry about what does this bit do, what does that bit do, or, I don't really understand how this is working. If you listen carefully now, and you'll see. So these are all the different parts of a microscope, okay? And I'm going to go through them one by one in a certain order and explain to you how they work. Okay, so let's start with the stage. Okay, now the stage is the thing that you put your sample on. All right, and it's this black thing here, okay, this black slab here. It's the thing that moves up and down. Okay, all right, so this moves up and down. Okay, and you put the slide on here. All right, so the slide. Okay, the slide is the thing that you put your sample on here. Okay, and there's a special way to put your sample on, but the slide is this rectangular piece of glass. Okay, and there's different, depending on what kind of sample it is. Some of them you can just whack it on there. Other ones you need to use bits of sellotape to do different things with. But that's generally where the sample goes. Okay, now next, we have a light source. Okay, so what happens is the light source will shine up, okay, and it will go through the sample. So there'll be a hole in the stage, and the light will go up through the hole in the stage, through the sample, into this lens, through this lens, and then up into your eye. So your eye will be up here, looking down. All right. Now that's important because you'll remember from physics that in order for you to see something, light needs to go into your eye. All right. So if there's no light here, when you look down here, if there's no light going up through the lens into your eye, you'll just see black. You won't see anything. All right. So that's a really common problem that happens. Is you're in the classroom and you look in the microscope and you just see blackness and you think, oh, it's not working. Why can't I see anything? And it's because you haven't turned it on. You haven't turned the light on. All right. If there's no light, how can you expect to see anything? You don't walk into a dark room and start saying, why can't I see anything? It's because there's no light. So if you can't see anything, probably because there's no light. All right. Now, next we have the eyepiece lens. So in here, there is a lens. Okay. Now, generally, that's going to be a ×10 lens. Okay. So that's going to make the actual length 10 times bigger into the image length. So that's thinking about what we were talking about up here with the actual length and the image length. That's going to be 10 times. Now, these three here are the objective lenses. Now, the objective lenses will come in 3 magnifications. Now, depending on the microscope you use, I haven't got a microscope here at home. I left my microscope at school, so I can't remember exactly what the objective lenses are. I think they're usually something like it'll be ×10, one will be ×10, one will be ×20, and one will be ×40. All right, now, so you can see that you have increasing magnifications to make larger image sizes. But it's important to remember, if you're using the ×10 lens, your magnification isn't ×10. Because let's say that this here is the ×10 lens, this is ×10. You're going to get ×10 magnification here, but you also get ×10 magnification here. Okay, so that's going to give you ×100 magnification, because it gives you 10 here and 10 here. Likewise, this is going to give you ×200, and this would give you ×400 magnification. All right, so when you combine 2 lenses together, you need to multiply the numbers together to get the total magnification. All right. Next, we've got to do the focus. All right, so far we haven't done anything with moving knobs or anything like that, and we've got our magnification. All right, so the magnification comes from moving between these. So if you want to see a larger image, you need to change your objective lens. All right, so what does all the knob twisting do then? Well, the knob twisting doesn't change the magnification. I'll say that again. Turning the knobs does not change the magnification. All right? The magnification is changed by using different lenses. Okay? These knobs here, the clues in the name, they change the focus. All right? So these guys, they change the focus by moving the stage up and down. Okay, so changing these knobs, so you might be there turning these knobs and it will move the stage up and down, but you're not making the image any bigger or smaller. All you're doing is you're making it turn from this fuzzy image into this clear image. Okay, but you can see the size hasn't changed. All right, if you want to change the size, you need to switch to a different objective lens. All right, and that's a really subtle piece of information that a lot of people don't really understand. They just think, oh, well, if I'm moving these knobs, I must be making the image bigger. You're not. You're just changing the focus. And when you go into school and you use one, you'll be able to see, because as the image becomes clearer, it doesn't become any bigger. All right, excellent. So make sure you've got some notes there to show what each part of it does, and make sure you understand, firstly, that the knobs are changing the focus, not the magnification, and that the total magnification is a combination of the objective lens and the eyepiece lens. All right, and then we can move on to the instructions on how to use a microscope. Okay, so this is how you use a microscope. All right, what I'll do is I'll put my image up here so we can see it as we go through it. Right, number one, move the stage to its lowest position using the coarse focus knob. So you use the large knob to move the stage all the way to the bottom. Then, select the objective lens with the lowest magnification, so you can twist this round to get ×10. Number three, place the slide with cells on it onto the stage. So it goes on, you can use these clips to hold it on. Number four, raise the stage to its highest position, but do not allow the slide to come into contact with the lens. So now use the coarse focus to raise it up so you don't even look through the eyepiece at this point. Okay, so you put the slide on and you look at it from the side as you twist this knob to get it up as high as it will go without touching the lens. All right, and then, only then, now we're at stage 5, and this is the first time that we actually look in the eyepiece. All right, so you'll see a lot of people, they'll get in the microscope and they'll just start looking in the eyepiece straight away. Those people, they don't know what they're doing. Okay, don't be that person. Think to yourself, right, there's a lot of stuff I need to do before I even look into the microscope. So now you can look into the eyepiece lens. And then you can start to use the coarse focus to slowly twist it to lower the stage, all right, and looking until you can see the cells. Okay, so you might not be able to see anything clear. You should be able to see some light because the light's on, but you won't be able to see anything really until you twist it and eventually you see the cells. Once you see the cells, then you switch to the smaller knob, which moves the stage by a smaller amount, and then you can get it into focus. Okay, now if you want to see the cells bigger, you don't twist the knobs, you change the objective lens. Okay, so you leave the stage where it is and you switch to another lens, and then you use just the fine focus. You don't even use the coarse focus now, just use the fine focus. Okay, so it's really important that if you want to, we all want to be proper scientists. We need to be serious when we're looking through the microscopes. We're not in year 7 now where it's something that we play with. This is, this is something that we can use to understand what these cells look like. So you need to be serious when we're using the microscopes, and those people that are serious will be following these instructions. All right. So make sure you're very clear what they are. You might want to put them on a flashcard. You might want to test yourself on the different stages of using a microscope. Now, as previously mentioned, it is easy to look at a picture like the one below and mistakenly think that cells are two-dimensional. Now, I got these from the textbook. These are onion cells, and this might be a practical that you'll do. All right, now you might think, look at them, they're flat cells, all right, with a nucleus. They're not flat. Okay, they are three-dimensional structures. It's just that because we're looking at them from one direction, they look like they're flat. Okay, and you can see they're all different shapes. Okay, in fact, it is important to remember that cells are three-dimensional structures that more look like an unbroken egg rather than a fried egg. Imagine if you had eggs, unbroken eggs, and you had a big batch of unbroken eggs, and you looked at them from the top. If you didn't understand that they were three-dimensional, they'd all look flat. All right, but they're not. They've got depth. Okay. Now, cells are generally colorless. All right. There's not, you can't really see anything. Okay. Which means that we need to stain cells. In other words, we need to just add a bit of color to them so that we can actually see them. All right, so these three stains are common stains. So if you add methylene blue, you'll be able to see the nucleus of an animal cell. That will highlight that. Iodine solution can be used to see plant cell nuclei, and crystal violet can be used to see bacterial cell walls. So just depending on what kind of thing, what kind of feature, what kind of subcellular structure you want to pick out, will determine which kind of stain you want to use. Now, some cells, they're fine. Okay, you remember perhaps we looked at stomata on the underside of leaves. Now those stomata, they were green on a purple background, so they were really, really easy to see. All right, not all cells will be like that. Okay, a lot of cells, they'll just be see-through, and if they're just see-through, you can't see them, so you need to stain them. Okay, excellent. All right, so that's some really good work today. What you need to do now is answer these questions. All right, so we've got questions 1 to 16. Now these questions will be on microscopy, but they'll also be on some of the cell stuff that we did last week. Okay, so things like typical size of a plant cell, you need to go back to last week's work as well. In general, which are bigger eukaryotic or prokaryotic, you should be, that information, you might already have that. If you don't have that, you need to go back to last week. All right, and some of this stuff is, is from year 9, right? It's good practice, okay? Including this one here. You're all going to love this question, okay? It's a very good question. Now, once you get down to question 14, okay, now we're thinking these questions are all about magnification. Okay, so this is a little bit mathsy. I want you to try really hard with these ones. Okay, I know how good you are with maths, so I want to see a really good effort with these ones. So, thinking about it, the eyepiece is a magnification of 10 times, the objective lens is 100 times. What's the total magnification? Okay, you should be able to work that out. And then if the actual length is 12 micrometers, all right, what is the image length? You should be able to work that out as well. If you're not sure, go back, watch that part of the video again, and you'll then be able to answer it. Okay, and like this time next week, I'll give you the answers, and then we'll do some chemistry. All right, so I look forward to speaking to you then. Keep working hard.